So we are starting with a question on what? Demand estimation. This question is actually what? A past question, 2017-2018 for what? With the weekend school. So variables, we were given constant, BZ, N, P, advert, coefficient, 450, minus 10.50, 8.45, minus 5.25, 1.5. So actually this was what the table being given. So let's start with the question. So I write the estimated demand equation for Donzano. So estimated demand equation. So the aims asking you to calculate or write the estimated demand equation for Donzano. So this is how we form the demand estimation. Okay. We know another name for constant is what? Intercept. And constant stands for what? Beta naught. Are you okay? Let's write down an equation first. We have this. Y naught. Beta naught plus beta 1 x1. Okay, with the B, we have beta 1, x1, beta 2, x2, beta 3, x3. All depends on the number of explanatory variables being given. So explanatory variable 1, 2, 3. So beta 2, x2, beta 3, x3. Okay. So another name for the beta naught is what? A constant or what? An intercept. So we have constant to 450. So that's it. 450. Okay. The next thing is what? The next beta, which is what? Beta 1, x1. Okay. So the next variable is what? BZ. We have this side for negative 10.50. So negative 10.50 times BZ. It becomes negative 10.50 what? BZ. The next one, plus 8.45 N minus 5.25 P. So I write the estimated demand equation for Donzano. So there's the estimated demand equation for Donzano. Okay, so that's how you form the demand equation. The first one, constant, is the same as intercept of beta naught. So there's the beta naught. So 450, there's the 450. B1, x1, it's negative 10.5, so negative 10.50 PZ. When you pick the coefficient is the same as what? Your parameter estimate. So if you pick your coefficient, you attribute or add it to what? The variable here, are you negative 10.50 PZ, 8.45 plus 8.45 N minus 5.25 PA. So there's it. Okay. Plus we have advert, so plus 1.50 plus 1.50. So 1, 2, 3, 4. So let's continue this. Therefore, x4. So we are done with the I. I'm moving on with the second question. I. Interpret the coefficient of income and advertisement. So interpretation of coefficient. We have various explanatory variables. You have PZ, N, and B, and advert. But with the second question, we are restricted. It said we should only interpret for what? Income and what? Advertisement. So this is income, M. Income is denoted by either a capital I or a capital M. So income is what? 8.45. And advertisement, advert, 1.50. So income. have an advert. So income, PA, so income. Sorry, income M. What was the value for income? Positive 8.45. 8.45. Okay. So that's how you interpret it. A unit change in the independent variable. The independent variable is what? The income. So any change in the independent variable, which is the income, will lead to a change in quantity demanded quantity demanded for Zanu by, it's positive, so we do it 8.45 units. But remember, when it's positive, it's what? In the same direction. If it's negative, in the opposite direction. So a unit change in the independent variable. Any change in the independent variable, which is what? The income, will lead to a change in quantity demanded for Zanu by 8.45 units. It's positive, so in the same direction. All things being equal. This is how we interpret the income. So the next one was what? Advert. So advert. Advert. Post 1.50. So the same thing. A unit any change in the independent variable. Which is advert, will lead to a change in quantity demanded for Zanu by 1.50 units. It's also positive, so same direction. The same direction. All things equal. So that's what the II was asking for. Interpret the coefficient of income in advertisement. So income, there's an N, 8.45. It's positive, so a unit change in the independent variable, which is the income, will lead to a change in quantity demanded for Zanu by 8.45 units. It's positive, so in the same direction. If it's positive, we use same direction. All things being equal. The same applies to the adverb, since it's also positive. So let's pick a different variable which is negative. Although it's not part of the question. Let's pick a different variable which is negative. Let's see how we interpret our one. So let's pick P. So P. Negative 5.25. So a unit change in the independent variable, which is the PA. This will lead to a change in quantity y, it's negative, so 5.25 units. Since it's negative, it's what? Opposite direction. If it's positive, same direction. Same direction. If it's negative, you still interpret the same way. But since it's negative, it becomes what? By 5.25 units in opposite direction. In opposite direction. All things being equal. So there's it. So all the interpretations are the same. It depends on the number. If it's negative, the ending use what? In opposite direction. If it's positive, in the end you use what? In the same direction. Are you okay? So you are done with the I. So you are moving on to the third question. So the third question, it states that with respect to income, what type of good is examine? So of good is for examine with respect to income. The third question states that what type of good is for example with respect to what? Income. Okay. So you come to the table. With income, we either use a capital M or what? A capital I. And they're asking what type of good is for example with respect to income. Whenever the question states that what type of good, they're asking for either a normal good or an inferior good. A normal good and an inferior good falls under what? Income. So you come to the table and check the variable or the letter for income, which is either a capital I or a capital A, and check the number. Is it positive or negative? If it's negative, then it's what? An inferior good. If it's positive, then it's what? A normal good. So there's N or an I, 8.45. So therefore, the good for example is what? A normal good. It's a normal good because it has a positive coefficient of income. Positive. So I'm moving on to question 4. I think. What is the relationship between Donzano and Alomopithes? Whenever the question asks that, okay, what is the relationship between Donzano and Alomopithes? What is the relationship between this commodity and the other commodity? They're asking about what? Either substitute good or what? Complementary good. The question says that what type of good? Normal good or inferior good? What is the relationship? Substitute or what? Complementary good. And you know that substitute and complementary good falls under what? Other related what? Goods, price of other related goods. So with the price of other related goods, we know that we have substitutes. We also have what? Complement. Okay, substitutes have positive values, complements have negative values. So price of other related goods, substitute or what? Complement. Substitute positive, complement negative. Whenever the question states what is the relationship, they're asking either it's what? So whether it was either a substitute or what? A complement one. So note that with price of other related, they either use PY or PZ. These are only the variables we use to denote what? Price of other related goods. Since the question is asking what is the relationship between Donzano and Alomopithes? And you know that they are talking about price of what? Other related goods. Come and check in the table whether you see the variable PY or you see the variable PZ and check the sign in front of it. If it's negative, then it was a complementary good. If it's positive, then it was a substitute good. So you come here. Do you have PZ? No, we don't have PZ. Let's check for. Sorry. Do you have PY? There is no PY. So let's check for PZ. We have PZ. There's it. What's the coefficient? Negative 10.50. So since it's the variable pH, the coefficient is negative. It's what? A complementary what? Good. Are you okay? So the relationship Zan and complementary goods because it has a negative coefficient. Negative coefficient of price of other related goods. Which is either a P1 or PZ. So you are done with the IV. So you are moving on to the fifth one. Test for the significance of income in advertising at 5% significance level. So 4. So the fifth question is asking us what? Test for the significance for what? Income in what? Advertisement or advert. Okay. So before you be able to test the significance for for the income in advertisement, unless you use what? The 5 pillars of what? Testing what? Significance. Are you okay? So first step, so testing significance. So we know with the first step, step 1, it states the hypothesis. Which is what? Either in null hypothesis. Which is denoted by H with a subscript 0. We also have alternative. A with a subscript HO. Okay. So the null hypothesis 1. There is no relationship. 2. Less than or equal to. Greater than or equal to. And it's equal to what? 0. Let me put it this way. There is equal to 0. With the alternative hypothesis, there is a relationship. Two, less than or greater than. 3, not equal to 0. So we have this, not equal to 0. So the next step, state the significance level or level of significance. Level of significance denoted by alpha. So let's take a question. If we were given level of significance, if there is no level of significance initiated in the question, we are going to use what? 5%. Okay. There was significance level being given 5%. So A is called 5%. So first one is state the hypothesis. Second one, you state the level of significance. Are you okay? Then do what? The first step, you state the hypothesis. Second step, you state the level of significance. So we have alpha to what? 5%. So 5% is 0.05. So by hand, you get 0.05. Are you okay? So that's how we do the step 2. So move on to the step 3. So step 3. Find the F statistics. Which is either a T curve or a T stat, which is equal to your coefficient over your standard error. So step 4. We find our critical values. So with the critical values first, we state the level of significance and divide by 2. State the level of significance. And divide by 2. So the level of significance is what? 5%. 0.05 divided by 2, we get 0.025. So the next step is you find the degree of freedom. There's still under step 4, find the critical value. So find your degree of freedom. So the degree of freedom is given by df is equal to n minus k minus 1, where n is the sample size or the number of observations, where k talks about the explanatory variables being given in the question. So let's check out for the sample size, the n. Oh, okay. There was no sample size in the question, but it's the same as what? Number of observations. So the number of observations is what? 18. So df n 18. K talks about the number of explanatory variables. So we have pz, we have n, we have p, we have average. Someone might ask, okay, why are we not adding constant? Since we know constant, it's what? Beta naught, and it's part of the regression equation. We don't add beta naught because we are talking about explanatory variables. We use this in getting the estimated regression equation. But when we are talking about explanatory variables, we eliminate the constant. So the explanatory variables are pz, income, PA, and average. So 1, 2, 3, 4. 2k, 4, yes, 12. We have 30. So degree of freedom 30. So now the next thing is we now have our level of significance when we divided by 2. So we now have 0.025. We have our degree of freedom to what? 13. So we will come and set for the level of significance, which is 0.025, and the degree of freedom, which is 13 on what? The table. So basically, with this, you'll be given a table where you use the level of significance you had, the 0.025, and the degree of freedom, which is 13, to find the theta. The combination of level of significance and the degree of freedom and the critical value should give you theta. Theta is theta related. So let's get on the table. You have okay. So with the level of significance, we pick it. This is how the table looks like. With the level of significance, we pick it on the horizontal axis. So level of significance. Then with the degree of freedom, we pick it on the vertical axis. So degree of freedom. So df. This side is alpha. Okay. So now 0.025. So 0.025 on what? The horizontal axis, the degree of freedom 13 on the vertical axis. When we set it on it, we are going to get the degree of freedom to what? Degree of freedom 13. We have degree of freedom pick 13 here. The level of significance will pick 0.025. So you will be getting 2.160 when you set it on the table. So now our T tab is what? 2.160. 160. So the fifth step, step 5, decision unit. So the decision unit, we have our variable. We have our coefficient. We have our standard error. Standard error. We have our t-curve. We have our t-curve. Standard error. The very stage that we should test for the significance of income in advertising, meaning that only income in advertising. So income M. So there's the variable M. So M is what? Okay. So coefficient M 8.45. 8.45. Standard error 5.68. 5.68. And advertising, so adverts coefficient 1.50. Standard error 1.0. 1.0. Okay. So to be able to get a T calculated, or the T statistics, we divide what our coefficient over what standard error. So to get a T cal for income, we divide 8.45 divided by what? 5.68. So we have 8.45 divided by 5.68. You have 1.49. So now, advent 1.50 divided by 1.0. 1.50 divided by 1.0. 1.5. Let's say 1.5. Let me show the calculation here. Income. So your coefficient over your standard error. So coefficient of income 8.45, standard error 5.68. You get 1.49. Advert E. Say it's coefficient. So coefficient for advert 1.50. Standard error 1.0. We get 1.5. So there's it. So income 1.49. Advert 1.5. There's it. Let's say it's your theta. The theta will be 2.160. So you just fix it inside. So 2.160. 2.160. So now, there's what we talk about when we are trying to explain what the decision means. So the next thing is you are supposed to conclude. How do you find do you find
The theta.
the theta? For you to be able to get a theta, we have 5 processes. First, you state the hypothesis. Second, you find the level of significance. Third, you find the L statistics. Fourth, you find the critical values. Then the fifth one, you find the decision rule.
Okay, so which approach did you use?
It doesn't have any specific approach. It's a
Any
format.
of the 5?
No, you use all the 5 to get the answer.
It's very okay.
So we have this. So now we need to conclude based on what our decision. So we should test for the significance of what either income and what average. So so conclusion. You have income. So that's how you'll be able to test for the significance of what? For income and what advertising. So that's how you do it. If your TCAL, we are dealing with the income side. If your TCAL is greater than your TCAL, we reject the null hypothesis, which is what? A false statement, making it what? Significant. If your TCAL is less than your TCAL, we fail to reject, which means what? A true statement, making it what? Insignificant. Are you okay? So 1.49, that's 2.160. So TCAL is what? Greater than what? TCAL. So we fail to what? Reject. So you fail to reject the null hypothesis. Which is a true statement. Making it insignificant. The next one, advert. A. So advert, theta 1.5, theta 2.160. So the theta is less than what? Theta. So when your theta is greater than your theta, we fail to reject. So the theta is also greater than what the theta for the advert. So we fail to reject the null hypothesis, which is a true statement, making it insignificant. So you conclude that okay, then since my income in the advert I was asked to test for, my income is what? Insignificant. My advert is also what? Insignificant. And we're giving level of significance to what? 5%. So 5 minus 100 is what? 95. So we are 95% confident that our explanatory variable, which is the income, and advert are what? Insignificant. We are 95% confident that our explanatory variable explanatory variables, income and advert, are insignificant. That's it. So basically, with the question 5, with a vein, that's all what they need, only this. But before you're able to get this, unless you use the 5 processes, that's all it is. So we are 95% confident that our explanatory variables, income and adverts, are what? Insignificant. So we are done with the vein. So we move on to the vein. So we move on to the next question, vein. The vein is teacher. Given that price of Zanu is 40 cedis, income 100 cedis, price of aluminum is 20 cedis, and expenditure on advertising is 80 cedis. Calculate the own price and income elasticity of demand. So we do it. So own price. Own price and income. So we are asked to calculate for what? The own price elasticity of demand and what? Income elasticity of demand. So we will start with the own price first. So with the own price elasticity of demand is given us. That's how we denote own price elasticity of demand. EPS is equal to not percentage, proportionate change in QoS or proportionate change in PS. Okay. So we have differentiate QoS with respect to PS. The one down here, the pH, moves upward. So we have pH. This set comes down with QoS. So we have this. Someone might say that, okay, I know that with own price, we have P2 minus Q1 divided by P2 minus P1. So why are we not using that one, but we are using this approach? We use that approach for business economics. In managerial accounts, we differentiate the demand funds to get what? Get pH. You get the difference. Okay. So now, pH. Given that price of Zano is 40 cedis, meaning price of Zano is what? 40 cedis. So BA is 40 cedis. Income 100 cedis. Income. $100. Price of aluminum. So own price elasticity of demand. If PX is proportionally change in quantity of X, or proportionally change in PX, we differentiate QX with respect to what PX. So PX, the question was talking about what? Don what? Zan, are you okay? They were comparing Don Zano with what? Price of what? Alomo, are you okay? So price of Alomo is what? The price of what? Other related what? Good. So PY is what? 20. Are you good? Give it a difference. Price of Alomo PA 20. Price of Zano PZ 40. The table below shows the regression result. Estimated Zanofa Limited. Local producers, non-alcoholic beverage, Don Zano. So, but we don't have the quantity, but we're giving all the variables. Are you okay? So you put in all the variables into the estimated regression equation, then we get what? The quantity. QS 450. $10.50. PZ 46. Income 100. So P 8. So 450. Is 8. So our quantity is what? 890. So 890 is quantity unit. You can decide to leave it 890, you can decide to add a unit. It's still correct. So own price. Okay, so you have, then the confusion side, you have PZ, we have PA, are you okay? How would I know that with the own price elasticity of demand? I'm going to use the price of PA, I'm going to use the price of PZ. We know that we denote cross price with what? Either PZ or what? PY, are you okay? So meaning this is what? Out. We get it. BZ and BY is what? Other related group. So meaning we are going to use the price of what? P 20 cents. PX. 20. We have quantity. QS. 890. Okay. How then do we get this? You pick the quantity, sorry, the estimated regression equation. Then differentiate QS with respect to what? PX. So we have this. We have 4, 10, 5, 7, BZ. We are going to differentiate QS with respect to what? PX, IUK. PX is for what? The price of what? Aluminum. IUK. So we are going to differentiate this with respect to what? The price of aluminum. It is what? PE, IUK. A is advertisement. That is price of what? Aluminum. So we are going to differentiate QS with respect to this. And since we are going to differentiate QS with respect to this, anything you see here apart from PE is what? 0. So this is not PE, it's out. This is not PE, it's out. This is also no PE, it's out. This is also no PE, it's out. So now, you are left with this, negative 5.25 PE. Then you pick the coefficient of what the PA or the number attached to the PA, which is what? Negative 5.25. So if you are differentiating Q with respect to PA, we have negative 5.25. So now we have this. We have PX to be 20. We have QS to be this. So now we can solve for their own price. We have negative 5.25. PX 20. 890. We have EPX to be equal to negative 0.12. We own price if it's less than 1 inelastic, if it's greater than 1 elastic, if it's equal to 1 neutral, if it's equal to 0 fairly inelastic, if it's infinite fairly elastic. Are you okay? So this is negative 0.12. So in normal instance, we know that since this is negative 0.1, what's less than 1, it's what? Inelastic. But this inelastic is correct. We do that in business economics. When you get this, I guess that their own price and still demand is what? Inelastic. But based on managerial economics, when you get to this point, you need to take what absolute values of what this. So the actual one is what inelastic. But if you take absolute value of it, it becomes what? Positive. So EPX. So it's no more what's negative but what's positive. So it's what? Elastic. No, it's still inelastic. Elastic is greater than 1. Inelastic less than 1. But the absolute value removes the negative there. Are you okay? Therefore, there's no price as still demand. We are done with the own price. We move on to what? The change department for own price and income. So there's the own price. We are moving on to what? The income side. Income is denoted by either a capital I or an A. This is the formula. Income, EI. For proportionate change in QoS or proportionate change in income. So you differentiate QoS with respect to income. So what's here comes down? Income. What's here comes down? QoS. So what is the income in the question? Income is 100 cells. So income 100 cells. QoS. It's what's the QoS? 890. So meaning that we are going to differentiate what? The QoS with respect to what? Income. So we have QoS. So differentiate QoS with respect to income. Income is either an I or a capital N. So there is the income. Okay. So differentiate QoS with respect to income. Okay. So anything you see here apart from N or a capital I is 0. So there is no an income. There is no an I or an N. So it's 0. 0. 0. So you are left with what? Yes. 8.45 N. So we then pick the number attached to N or the coefficient of N. So we have 8.45. So now cancel off. We have just cancel the differentiated one. So 8.45. Okay. Income 100. QoS 890. So in income, if it's positive, it's what? A normal good. If it's negative, it's an inferior good. So the income, therefore. So you are done with the vein iron. We are left with the last question, vein iron. Comment on the value of R squared. So R squared, just like 0.690, 0.69075. So on our previous note, the same interpretation. An R squared of 0.690785 implies that all the explanatory variables explains, then rest times 100. .08% of variations in the dependent variable. So that's how we interpret R squared. if it was supposed to be adjusted out square, when you get this side, you add taking into consideration the sample size and the number of what explanatory variables. But with out square, you only end here. Are you okay? So basically, so you are done with demand estimation based on the weekend school question 2017-2018. So you will solve a different one.